Hey everyone, it's Justin again. In the last video, you learned how to use slopes to differentiate between linear and exponential growth in data. In this video, we'll expand that concept by looking at how those differences in slope translate to visual graphs that model the data. Here's one of the data sets from the last video. We decided that it was linear because it had a constant slope of 3. But what would this look like visually? Well, like this. When we graph all the points in the data set, it becomes very easy to see why we call this relationship linear. The points are in a straight line. The slope of this line is 3, the same as the data. This line is what we would call a model of this data. Here's the same exponentially growing data from the last video, with slopes that have a common ratio of 2. If we graphed the points, they would look like this. If we tried to draw a line with the same slope as the first 2 points, it would go way below the later points. A line with a slope of 6 still isn't steep enough, and neither is a slope of 12. In fact, no single slope is enough because this data keeps getting steeper and steeper forever. So a constant slope just can't keep up with it. This is why a linear model isn't enough. We need an exponential model that keeps getting steeper as it moves to the right. Which of these data sets is represented in the model? The graph shows data that grows exponentially. The first data set increases by a constant amount of 6, so it would be linear. The second set of data increases first by 6, then by 18, then by 54. The amount of change is tripling each time, meaning this data is growing exponentially. So of these two sets, the one on the right is best represented by the model. What do you think about this one? The data on the left grows by a constant amount, while the data on the right grows by bigger amounts each time, multiplying by 5. So the left data set is linear, and the right data set is exponential. This model shows linear growth, so it best represents this linear data set. It's easy to recognize the difference between linear and exponential models even without grid lines. Which data set do you think matches this model? On the left, the values increase by greater values over time with a common ratio of 3. On the right, the values increase by a constant amount. The data with exponential growth on the left matches the exponential growth model. Linear and exponential growth are just as easy to distinguish visually as they are by using the slopes. In the next lesson, we're going to learn how to use exponential growth to predict future events in real-world scenarios. See you then.